Hello, I'm Laura Lewis. Welcome to the class on energy transfers or energy transferred. This is part of GCSE physics. I'll get on with the video. So, the learning aims or learning objectives for this are understand that energy cannot be created or destroyed, only transferred from one form to another. Number two, combine different equations for energy and power in exam questions. And name the different types of energy alongside useful and wasted energy. We talked about useful and wasted in a different video, but this one we're actually looking at the actual types. Okay, types of energy. So it's like a basic sort of image board. Okay, it's a good thing to do actually. If you copy this, it's actually quite good. It's nice easy notes. So kinetic. So that's moving energy. So anything that's moving has kinetic energy. All particles, if they are above absolute zero, so they're above minus 100, so minus 273 degrees Celsius, have kinetic energy. So everything does, but especially moving objects. Okay, so example, throwing a ball. This is like a ball being thrown. That would be kinetic energy. Chemical energy. So often in fuel, that's supposed to be a conical flask with a chemical in it. The more you laugh, the more you remember. So I advise you to draw your own drawings. They have a bit of fun as well. So that's fuel. So things like petrol, diesel will be chemical energy. Okay, for cars. So talk about that a bit later. Gravitational potential. So anything that's up high. Okay, so this is to represent a satellite around the Earth. So if you actually pick something up off the floor, you're raising its gravitational potential. So the higher the object, away from the ground, the larger its gravitational potential. So the higher the object, the larger its gravitational potential energy. The larger the, and then it's gravitational potential. Okay, so elastic potential that's an elastic band, by the way. So it'd be elastic bands, even your muscles actually, they have elastic potential. So if you like pull your arm back so it's next to your shoulder and then let it go, that's got elastic potential because your muscles are quite elastic. Okay, so it's the energy stored in something that's obviously stretchy, elastic potential. Also springs, okay, have elastic potential in them. So anything, yeah, springy, stretch, anything like that. So like a slinky thing has got like a toy has got that a potential in it. Okay, electrical energy, that's probably the more obvious one. Okay, so electrical energy is energy of electricity. Okay, so things have electrical energy transferred to them. And then you have thermal energy, which is heat. Okay, so thermal is obviously the hotter the object, the more thermal energy it has. That's always the one that's quite easily remembered, isn't it? Thermal. Okay, so when we say about created or destroyed, we're really looking at the most fundamental law of physics or of all science. It's called the conservation of energy. So to conserve something means like to keep it, doesn't it? To keep it as it is. So energy cannot be created or destroyed, only transferred from one form to another. So energy, I'm missing a Y there, energy doesn't just disappear. Okay, it doesn't just come out of nowhere, it doesn't disappear in somewhere. Okay, any question, it will not do that. Honestly, it will not do that. Okay, so let's talk about some examples you might get in an exam. So a television, say what would go into that? Oh, obviously it's plugged into the wall. So electrical energy goes in. Okay, it's plugged into the wall. So what is that transferred to? Okay, that's that transferred to. In the television, it's two main things. Okay, so transferred to light from the screen. And also, so you can hear it, sound. Energy wasted. Okay, so wasted as heat or thermal. So thermal. So just good to make you think about these things. A kettle, I think that's actually quite a good drawing of a kettle. A kettle, so what goes in again? So electrical goes in. So all these have got electrical going. Most things do, obviously appliances, electrical goes in. What needs to come out really? Thermal, isn't it? So thermal is useful here. Okay, this is useful. I didn't write down the other one. So these are useful. Okay, what is wasted? Okay, obviously it's not thermal this time. Mostly it's sound. Sometimes a little bit of kinetic, isn't it? Because it makes it sort of vibrates a bit. So kinetic. Okay, a little bit of wasted there. So a light bulb, okay, again, electrical will come in. Okay, so what's useful here, which is light. Okay, light is useful. Wasted, thermal, a lot is wasted. Okay, thermal and light bulb, you know, it gets very hot. Okay, so in a radio, okay, so the radio, so again, electrical. If it's a battery, it'll be chemical. Okay, so I'm going to put that there. If it's a battery, we'll talk about that with the torch. That's why I included that. Okay, so useful, obviously sound. I want to hear it. So wasted. Okay, wasted would be thermal. Okay, torch. Okay, so torch is a another one. So that would go to chemical. So if it was chemical, yeah, I'm going to say something about this chemical. So chemical goes to electrical because usually it's got batteries in it. There's two stages to this. And then useful is light. Wasted will be thermal again. Lots of things, unless they're made for heating, waste energy is thermal. Okay. A car, okay, so useful. So it goes from chemical from the fuel. Okay, so that's the fuel. So useful would be kinetic, for it to move. Think about, we're saying about lights for light, that's from the batteries, that's a little bit different. So kinetic, and then wasted would be thermal and sound. Okay, so definitely gets very hot for that. So, okay, so we talked about energy and power and things. So just to recap, so power from another video, power is energy transferred over time. So if you have 60 joules over 30 seconds, there's a separate video on power as well, I'm going over a little bit here. So 60 joules over 30 seconds, so power is 60 joules over 30 seconds, and that's should be 2 watts. Okay, so this is a bit of a recap, okay, on power. Okay, so I'm just going to do one more bit here. So there's a bit of a recap about, so example, so if a car has 1000 joules of chemical energy, okay, this is a bit of a recap from other videos, and 500 joules is transferred to kinetic, okay, what is the efficiency? Okay, so remember efficiency equals total in, sorry, I mean useful out over total in. So useful out over total in times 100%. Okay, so useful out. So 500 joules was useful here. So it's identifying what is useful at the time. Total in was 1000. I'm sure you can probably see what we're going to get out of this. Times 100%. So it's going to be 50% efficient. Okay, so equations for power, energy, and work, they'll be all interchanged in an exam. So I've got a series of videos all about the same theme. So I recommend you watch all those videos. But thank you for listening and hope to see you in another video. Thank you. Goodbye.